Hi everyone. As we said before, these first few lectures and sessions to have a review over the materials or some important notations and concept from the grade 9 to start our new chapters from grade 10. So in this session, we want to review and have an overview over the approximations and how to round down or round up a given number and what we mean by significant figure. So first of all, why do we use approximation? So we have to approximate some result of a calculation to make the answer meaningful and has and put it into a comparison. So what do we mean by the value of the digit? We know that any number can be written with different digits and places. We have the whole part places, starting from the unit, to be clear, the decimal point of a given number, partition or distinguish between the whole part places and decimal places. So we're starting from the decimal point from right to left. We have the unit, the tens, the hundreds, the thousands, and the 10,000, and so on. And moving from the decimal point to the right, so we have the decimal places, okay, or the places of the decimal part. I'm representing by, in order, by tenths, hundreds, thousands, and 10,000s and 100,000s, and so on. So if they ask us to write the value of the digit 7 in each following number, so we have a 7 here, so normally it is the decimal point, so normally it is the unit, the tens, the hundreds. So normally it is the hundreds. Sorry for the big mistake that I did here. Hundreds. The 7 is here, so it is a unit. The 7 is here, so it is the tens. Rounding process, what we mean by rounding? We want to round to whole part places or to decimal places. So we have to round down or round up. When we round up a given number nearest to a given place. So, for example, first of all, we indicate the nearest, for example, we have this number and we want to round it to the nearest 100. So we search for the 100 place. The 100 place is here, therefore. So we compare the digit the digit located directly to the right of the 100. So we compare the tens digit 7. We compare it to 5. If this number is greater or equal to 5, so we add 1 to the hundreds digit and we put all the digits to the right as 0. So normally here 7 is bigger, greater, or equal to 1, to 5. So we add a 1 to 4 to obtain a 5. And we put, okay, and we reset all the digits to the right of 4 or to 5 by zeros. Okay, so here, when we add 1, so we rounded up. We rounded up this number. Moving to the next one, the nearest 10. We have, first of all, we indicate the number, the nearest 10. So the 10 is 5. So we compare directly the digit directly located to right of 5, 6. 6 is greater or equal to 5. So yes, we add a 1 to 5. We add 1, so we round up this number. We round up the 5 to obtain a 6. So 6, and we set all the digit located to the right of 6 by zeros. To obtain by rounding up this number, we obtain 7,960. Okay, to the nearest whole number. What we mean whole number? So normally to the nearest unit. Whole number, integer. So we don't want this decimal point. So we want to round it to the nearest to the nearest unit. So we compare this one. If 5 is greater or equal, yes, it is equal to 5. So we add a 1 and we put all these as zeros. So we obtain 38. To the nearest 1,000. So 1,000 is here. Okay, you can practice it and train yourself how to round up. All these cases are for rounding up and not for rounding down, as we remark. Round 7.2681 to one decimal place. How to count the decimal places? We start counting the rank of decimal places from the decimal point to the right. So one decimal place, second decimal place, third, and seven decimal place. So one decimal place is 2. So we compare 6. 6 is greater than the greater or equal to 5. So we add 1 to the 2 to obtain 7.3, and we put all the remaining digits to the right of 2 by zeros, and so on. How to round correct to decimal places? Also here, for example, it is in a special case because we have a nines. So for example, one decimal place is 9. So we compare 7. 7 is greater or equal to 5. So normally we want to add 1 to 9. And we know that by adding 1 to 9, we obtain 10. So it becomes 0, 1. So again, we have a 1 plus 9. It becomes also 10. So 1 plus 3 is 40. 40.0 it is like, and we reset 7 as 0. So normally we obtain a 40. Okay. What we mean by significant or how to find, for example, if we have a number was rounded to the nearest 10 and the answer was 50. So like we have like this is n is the k. Okay. So normally we can use this statement. It is very useful. So normally to find the smallest number that we could have, that could have been, or the biggest one, or the greater one. So normally the smallest number is equivalent to n minus k over 2. So it is a 45. 45 because if we round 45 to the nearest 10, this is the tens digit. So normally 5 is greater or equal to 5, yes. So we obtain a 50 after rounding it up. And the largest that the number could have been is 50 plus 10 over 2. But smaller, it is not equal, smaller, because if we round 55, we'll obtain 60. We round it up, but we want all the number or the largest number is strictly smaller than 55. The mathematical statement is that 50 can be equal, greater or equal to 45, but smaller than 55. So all the infinite set of numbers between 45 and 55 can be rounded up or down to 50. Moving on to explain or re-explain or have a small review about significant figures. So we want to know what we mean by significant figures. All digits that are not a 0 are significant figures, and how to find the first significant figure to start counting its rank. So we start by searching for the first digit that is not 0, reading from left to right. So we have done this number. So 3, it is the first digit. If 3 is different from 0, so we say that 3 is the first significant figure of this number. Okay, for example, in this example, we have 0.07. Reading from the left to the right, 7 is the first significant figure because it's the first digit that is not a 0. Okay, and we should know that the zeros between non-zero digits are significant, and the zeros at the end of a number may or may not be significant. So what we mean by that, I'll write the first significant figure in each of the following number is 1. We're reading from left to the right. So 1, here is the 3, here is 6. How to round to the following number of significant figure, like we rounded in the previous slides. So for example, what we first of all, we should locate only our search for the rank of the significant figure. The first significant figure was 6, so we want to round it to the nearest tens. Okay, second to the nearest unit or the whole number. 3, for example, to the nearest 1 decimal place, second decimal place. 5 is here. So normally, if we want to round this one, so 9, we compare 9 is greater or equal to 5, so we add the 1 to the 5 to obtain 306, and all these zeros, and so on. How many significant figures are there in each of the following number? 1, 2, 3, so we have a 3. This is not considered as significant figure because it is the first one of the first digits and 0 equal to 0. So 3 is the lone only significant figure for this number. It is 1. So we have here 7, 5, 2 significant figures. Very clear, we have 2 significant figures. And as if we refer to the definition, that zeros at the end may or may not be significant. So maybe we have 3 or 4 significant figures. We have here 2 significant figures, and we have here 3. Definitely we have 3. But we can say maybe or 4, 5, or 6. What we mean, the difference between measurement 4.65 meter and 4.650 meter, we don't have, in calculation, we don't have any difference between these two measurements, but we can say as a number, we have here 3 significant figures, but here we have 3 or 4 significant figures. Thank you for listening. These are the main ideas of approximations paragraph. Bye-bye.